Hello, and thanks for joining me once again in this wacky dive into the world of Azure Synapse Analytics. So one of the things that we've had requested previously is, can we have a look at how to read Avro files? And then another thing that we've had previously is, can we get some data out of an Event Hub? So I thought I'd jam the two together, show you if you're using Event Hub, you've got Capture turned on, that's going to spit out a ton of Avro files for you. How do we get a hold of them? How do we use the Spark pools inside Azure Synapse Analytics to go and query Avro files? Let's have a look. If you like the video, don't forget to like and subscribe. And if you get on with it, feel free to tell us in the comments. Okay. So I have an Event Hub sitting here. This is just a real straightforward Azure Event Hub. And an Event Hub, if you're not familiar, is kind of just a giant bucket in the sky for you to send messages to. So it's a cloud service that acts as a message receiver. So I can have a little local package or a sensor or an IoT sensor thing on my kettle or whatever it happens to be, spitting out messages constantly, firing them into this Event Hub. And the Event Hub is just a real easy space to receive those messages and start tracking them and ticking them along as they come through. Now, it doesn't have a lot of kind of schema enforcement, doesn't have a lot of kind of control over it. It's just fire messages at it. And then the things that are reading messages from it, they can do is that the right shape, is that the right structure, what's going on in here? So I've got an Event Hub set up called Message Stream. Inside there, I've got an actual thing set up called Sales Transactions. So I've got my Event Hub namespace, which is my general collection of them, and then the individual buckets, which are my things. So I've got Sales Transactions in my Message Stream, and that's where I'm trying to send some messages to. Okay, so that's fairly straightforward. And then I've got a little bit of code here. So I'm using the Azure Event Hub Python SDK. So just a load of existing classes I can just call to go and send data into an Event Hub. So I've got my Event Hub over there. I'm just doing some real easy stuff. I'm saying, here's a connection string. Throwing the connection string I can get from Azure. So if I'm in here, I can go in here, I need to go into my namespace, not my Event Hub. Go in there, and there's a load of connection strings in here. So I can just go and get a connection string from in here. Go, and I can grab that and put that into my code. So I'm grabbing that connection string, that's all I'm doing, into my little bit of Python. I'm doing some stuff to randomly generate a message. But the main thing is I need to create a new batch, assemble a message. I've got something saying, in my current batch, I want to add some event data. We've been passing that message in. And then doing client.send. Now, again, I know that is super quick. We're not going through the code of how you integrate with an Event Hub or anything like that. Just letting you know I'm sending some data up into Azure in the form of the Event Hub. So let's just go and run that. Kick that off. And we should see just a load of messages suddenly start to appear. There we go. So that's now streaming messages into my Event Hub, just firing them all off. So doing a couple of seconds. And then we should see that suddenly start to tick along inside my Event Hub. Okay, so that's step one, is just fire some data, get that working. So step two. Inside the actual Event Hub, I've got a thing called Capture turned on. Now, so Event Hubs, generally the whole point of using an Event Hub is so you can put some kind of stream compute against it. Now that could be Spark structured streaming, it could be Azure Stream Analytics, it could be other thing that can be essentially every message that goes in running some kind of compute. So you have like a Power BI dashboard constantly ticking and telling you the current variables. Now, sometimes you just want to get the data and land it. So you've got this fire hose of data constantly coming in, and you want to say, just put it down somewhere and I'll look at it later. Now that, for me, the easiest way to do it is a thing called Capture. So in Event Hubs, we've got this Capture Events, we've got this Capture tab sitting over there, and we can just say, hey, can you just like sort the messages out for me? So I've turned this on, I've set it every 2 minutes. So every 2 minutes, it's going to start a new file and start adding lots and lots of data into it. And then 2 minutes later, it'll start a new file and start appending data into it. So essentially, it's just automatically writing data down to the disk so I can go back and look at it at a later date. So I can tell it how big it should allow each file. I can say whether or not it should have an empty file. So if I'm in a minute and I've got it turned off, should it just create these dummy placeholder files? Or just go, no, I'll just create files when there's actually data. Then a load of stuff. I'm pointing it at a lake. I'm pointing at the lake I normally use that's got all of my other data in there, and I'm just treating it like any other data source going into my first raw folder. I can give it a format. So I'm saying, well, actually, this is the directory structure. There's lots of things in here which are dynamic. So just create something with the namespace, the event hub, the partition ID, or the year, month, day, and I'm doing that Hive style, so I can do partitioning. So if I read this via Spark, it'll see those folders, year equals, month equals, and it'll just treat them as partitioning columns as part of the overall data set. So I'm just saying, can you automatically make my data in a readable state? So I've got that turned on, and I'm sending data through. So we should, if we have a look in our actual lake, got my root folder, go still down and down and down. So we've got our raw folder. And then I've got my stream, mesh stream, that's the namespace, sales transactions, that's my event hub. My version, I've then got, say, year, month, day, all the hours I've had this thing running, see the minutes. So this is going in and it's creating files. So you can see kind of what it's 14. So that's currently actually going in, creating a file, adding more and more stuff into that file. And then as this goes, we'll see it add more and more minute buckets into my thing. So that's capturing data. That is live, getting data, landing it down into my lake, storing that data for me. That's great. I can actually go and access that. I can go and work with that data. The big question we had, how do we get at that with Spark? Now, I was expecting this demo to be very, very different. So in Databricks, they made a Spark reader. There's the kind of Spark-Avro library, which was created by Databricks. They open sourced it and donated it, made it part of the core Spark project. And when we originally had Synapse, pretty sure that didn't work. I had quite a few people going, why can't we read Avro? So I'd assumed this demo is all going to be about taking the Spark pool, adding a custom library, showing you how you can import your own libraries into the Spark pools. But actually, it just works. It just works out the box. It's fine. So I'll do that in another video. Here we can do spark.read format of Avro. So unlike the other ones where we've had .parquet.csv and you're using the inbuilt readers, we're saying .format Avro using a generic loader and giving it the path in the lake. This isn't the primary lake that the Synapse is built on. And I'm just saying go to that root folder. So I'm not saying year equals, month equals, day equals. I'm saying just treat it all as one giant data frame, and then we should see the different folder structures underneath it. So that should work. If that can understand Avro, then that should just run, shouldn't give me an issue, and then I can just do a display and say, well, what does my Avro file look like? So that executed, so that's obviously a good sign. And then we'll see it does come out in a little bit of a funny structure. So you remember the kind of inside the stream, I'm expecting device ID, sales amount, number of items, that kind of thing. And then actually, when we actually get this back, we'll see something slightly different. It's because Event Hub is essentially receiving the message and then packing that message inside kind of a superstructure. So we see some other things in there. So we get sequence number, offset, we get the enqueued time UTC. And then our message is actually hidden inside this body. So it's converted into kind of a binary string, pressed down, so we can't actually see what's inside our body. And then you can see we've got those partitioning folders. Year, month, day, hour have actually been exposed as virtual columns that is actually derived from our folder structure. So having that inside your capture is great. And again, that's an Avro file. So that is stored as Avro. If we drill down right into kind of the bottom of that, that is a .avro file. And that's just reading it natively. So that's awesome in that the Spark pools, so Databricks, Synapse, whatever it is, you can do .format of Avro and start reading those captured Avro files. Okay, right, so what do we want to do with it? We want to actually see what's inside that body. So all I'm doing is saying, firstly I need to import the PySpark SQL functions, saying, okay, replace my data frame with a new version of that data frame that has a transformation applied, replace the column body. So that already exists as a column saying take body, which is that horrible GUID string, not GUID, but you know what I mean, and replace it using a SQL expression saying cast body in a string. I could have written that as PySpark, but that's lazy. And that's just going to translate it back into its original structure. So we just do another display on there. We should be able to see what's the contents of that body column now. There we go. Okay, so I can now see inside there, I've actually translated it back, and I can go and actually see what's inside that message. Now that's still a little bit hard to get at. That's still JSON packed inside a particular column. So there's a few different ways you can interrogate that. I could use this from JSON, which requires a schema. So I could like sort of build a little schema struct and say, unpack that, turn it into this structure. if I'm being lazy and I've just got a couple of things I need to pull out, I can use that JSON tuple. So I'm saying, again, overwrite my data frame with a new version of that data frame, .with column, add device. So I'm appending a new column called device, saying we'll interrogate body, treat it as if it was a JSON tuple, and see if you can pull out the device ID. And I'm doing that 4 times, saying the device ID, the sales amount, number of items, and the process date. And then hopefully we can then go and have a look at that and say, what are my extra columns? So again, just do a quick display on that. Have a look, see what's going on inside there. It's working. There we go. Okay, so we've got all our original columns, we've got our partitioning columns. There we go. So we've got device, sales amount, number of items, and process date. I've managed successfully to unpack particular things from inside my, and then might want to do this kind of thing. Might want to say, let's go and do a query, pull out, aggregate it by hour, minute, sales amount, that kind of thing. And this is where it's going to get interesting. So this should work quite happily. It's just doing a quick aggregation. However, we'll start to see a bit of funny behavior. Let's this run, think about it, running a few tasks, lots of jobs going. Don't like that we don't get however many jobs there are at the start of these things. Okay, there we go. So I've got my data coming back. See a whole range of hours being shown in here. 8, 9. So I've got 9, or well, 9, 14 is the latest one I've got. Okay. So if we go back in here and we go up a little, we can see I've actually got minutes 16 and 18. So there's data that has been landed to my lake that I'm not seeing here currently. So I would expect to see 9, 14, I'm not, and 16, but I'm not. So even though I'm continuously streaming into it, what I'm actually seeing inside my thing is a static view of the data. So if I hit run all, I'm just going to run it right from the start. Maybe it's a crashing issue. Maybe we can go right to the start and try and work out what's going on. Next, I'm going to do that again, but without all the displays. Otherwise, that's going to go slow. Now, the interesting thing that's doing here is it's caching. So essentially, it's automatically taking a snapshot of the data at the state when I first query it. And then even when I query it again and say, show me the new data, it's still going from that cache that exists on my Spark pool. And that's a little weird for me. So again, I'm expecting to see 9, we've got 9, 14, 12. I don't have those latest ones. I don't have 16 and 18 in repairing. And again, we're seeing more as it goes. So how do we get it to go back and actually show us the latest data? It's a little bit weird. So this is the behavior I would expect if I had dataframe.cache or dataframe.persist. Now, both of those are commands I can apply to a data frame to say, hey, take a snapshot of this as you pull the data through, take the data, keep it in memory on my Spark pool, and then next time I ask for it, don't go back to the disk, just get it from memory. And it's a performance tweak that I can do when I know that I want to cache. Now, what has happened here, it's automatically cached. So under my config session, I can go up to the Spark UI, and I can say, show me the Spark UI from my current Spark pool. Again, my slight pseudo cluster that got turned on. I can see all the jobs I've had running, and I've got that all-important storage. Now, storage will show me what is currently cached on this cluster. Remember, I didn't say cache or persist anywhere in my script, but I've got a whole ton of things that have been cached. I can see it's actually stored it in memory, the different cached states of my data frame. So without me asking to, it said, hey, you know what? They've asked for some data. I'm just going to cache it regardless. So this is obviously a performance optimization that's been put in by the Synapse team to say, people never remember to cache. We're going to cache for you. So that's what's happening. So even though I'm saying, show me the latest data, it's not going back to disk. It's going to the cached version, which isn't aware of those 16 and 18 folders. So I ran my first query, I ran the first of the data frame when minute 14 was still there. It's not gone back and found those latest 2. So I can kind of trick my way around it. I can say, so the way I'd normally do that is, as you saw, I had that code in just when we first ran it, I might say data frame unpersist. Now, if I've manually cached a data frame, that goes and says, get rid of it. I want to see the fresh copy of it. But then again, I'm not seeing that under 9, I'm not seeing those 2 1618. So again, it's not working. So even if I'm telling the data frame unpersist, the caching that's happening automatically in Synapse is ignoring it. So the caching layer looks like it's separate. It's not like an automatic cache has been done that I can then unpersist. There may be a command that I can tell it that drops that and goes through. I've not found that yet. And again, if you know that, let me know in the comments and I'll have a look. But yeah, a little bit weird that I can't override it. I have to go from cache. Now what I can do is I can just say, well, actually, let's change this a little bit. Let's go, just add some globbing syntax, which just kind of change how it's working. It's kind of saying, it's still getting the same data. I'm just kind of forcing it to read all the files in there to work out what it needs rather than just use the native partitioning. Just a little tweak. And then what we should see, 916. So now because I've changed it, it's no longer hitting that cache and it's now bringing that data back. But if I insert a load more data and I ran this again, it would still be using the cached version. So a little bit weird. And I'm kind of curious to see how that works. I guess a lot of the patterns that the Synapse Spark implementation is expecting is kind of, I'm running a Spark job. I have something that's on a regular schedule, it starts a Spark pool, it does a load of work, it turns that Spark pool off. And then we're never going to encounter this. We're never going to see it having issues when I'm trying to refresh it. I'm trying to go back to the source data because my session will have been stopped and restarted in between. So it's only when I've got something like this, when I'm interactively inside a notebook and I'm refreshing it going, wait, why is that value not changed? That's when it'll be hitting the cache and not telling me. Now I'm assuming I can just actually say, you know what, let's go on my data frame, let's do an explain. And we can see, So that's interesting, because that isn't saying it's going from in memory. Like it's not saying it's hitting the cache. It's saying this is going to be a file scan. So it's like the implementation seems to be a little bit different. Again, interesting. So we can't predict based on looking here that it's going to go and hit that unless there's something in the detail that I'm missing, which might be. So yeah, interesting stuff. Be a little bit careful about that. But so the main messages there is one, Avro now works out the bugs. Whether it did or didn't originally, it now does. You can use that format Avro, and then it can just read Avro files natively. No extra libraries, no extra awkward installing a file reader. You can just say spark.read, format Avro, and go nuts. Two, if you're using Event Hubs, don't forget you can use Capture, and then you can give Hive-style partitioning to the Capture. And that makes it really, really, really easy to read with Spark, and you can just go from there. So you don't need to invest in having a Spark cluster permanently turned on, in having Stream Analytics just to say, take the data, land it in a lake. If all you're doing is making the data accessible to downstream things, then just switch on Capture. It does come with an extra cost because you're using some compute somewhere to land that data, but it's a fairly cheap, fairly easy, and fairly robust way of landing that data down. When you've got that data, don't forget you need to unpack that body so you can get at the individual different variables. And be very careful if you're in a Synapse Spark pool, because it is doing some auto caching behind the scenes, which is going to be great for doing like one-off jobs and reusability and just essentially performance tuning things as a little bit black box. If you're running something and you're expecting it to change, there's got to be some way of getting it to go around that, or you can just change your data frame definition very slightly, and then it's going to avoid that cache and go straight back to the disk. Lessons learned. Very different demo than I was expecting, but interesting times. Lots of interesting stuff inside there. So if that's something you think is going to be useful, if you're going to give it a go, if you do give it a go and you manage to get it working in a different way, let us know down in the comments. Don't forget to like and subscribe, and I'll drop a couple of videos that might be of interest to you on the side. All right, until next time, see you again.